Well, hi, good morning. Thank you for joining me in my shop here. It's May 15th, the middle of May. So yesterday I did some interesting experiments, some stuff that's always been in my head, but I've never really taken the time to try it, and I thought this radio might be a good radio to try it. And yes, it was a good radio to try this stuff on, and here's the results. If you watched the last video, which I imagine you did, before watching this, then you would have seen me working on this chart, and you got a little glance of it right at the end of the video, and I said something about I'm going to go away and look at this and study it and that. Well, there's some interesting stuff on this chart that I surely do understand, and then there's a little bit I don't. So let's just go over it very quickly here, and then we'll get onto the radio and investigate a few of these curiosities a little bit further. So, broadcast band, and then the three shortwave bands. This band going all the way from about 13 megahertz up to 30 megahertz. And this one just being a broadcast band up here. So the broadcast band behaved in a normal way. I could put it that way. You get what you tune in, and there's nothing funny going on up here in terms of images and stuff like that. The next band down, some interesting things started happening. So I had the radio tuned at 3 megahertz. I've marked where the radio was tuned during each of these tests. This here was tuned to 8 megahertz and left there, and here it was tuned to 20. It just stayed there. So here it's tuned to 3 megahertz, and let me try to remember how I did this now. I found when I tuned, when I placed a signal generator signal on the antenna at this frequency, 3914, you could hear it. Even though the radio's tuned to 3, you can hear it at 3914. So this is the image. This is the other side of the local oscillator. I've drawn the local oscillator frequency vertically with an arrow, vertically with an arrow, vertically with an arrow, and I've drawn the proper image response, if I can say proper, with an X. So I put an X there, put an X there, put an X here, down below. Yeah, so this one is above the local oscillator. The local oscillator is above the target frequency. Same thing here. This one I got the other way around. Now I remember trying to sort this out first time I aligned the radio and concluding, I thought I concluded that the local oscillator needs to be above. But that's not where it is right now. It's below, so maybe I just can't remember what I did. And I tried to set the local oscillator above or below in accordance with which one gave me the most distinct, the largest image rejection ratio is the way I should put it. And I concluded from that that's where the local oscillator should be. I can't find any information on where the local oscillator should be, above or below, for any of these bands in this radio. Okay, so that's kind of the normal part, except here the local oscillator is below the target frequency for reasons I just explained. Now let's look at some funny business. Let's look at this funny business over here. So as I was tuning my signal generator from way high, I noticed that as I crossed certain frequencies with the radio tuned to 3 megahertz, I'm picking up this stuff. I picked up something at 6.4 and something at 7. What did I write there? 7.3. Later in analysis, I realized that this is roughly 900 apart, these two signals. 900 apart. Well, 900 is double 450. 450 is the IF frequency, roughly. So down here on this band, the same thing happened. Way up high here, as I tuned my signal generator down, even with the radio tuned to 8, I picked up a signal at 16.4 and another one at 17.3, and they also 900 apart. So now I realize, and if you've been looking at my diagram, you might have spotted it. If you take the local oscillator frequency with the radio tuned to 3, the local oscillator is running at 3.455. If you double this number, you get, did I write it in here? I may not have written it. You get, well, what do you get? When you double, basically 3.5, you get 7. So there we are, 6.9. And 6.9 is in between 640 and 7.36, right in the middle. what's happening is the local oscillator has a harmonic. So not only is the local oscillator producing 3, 4, 5, 5, it's also producing roughly 7. Or here, 6.91 as I measured it. So this is going to be weaker, not necessarily a lot weaker. We saw in the SDR that there seem to be many versions of the local oscillator. So here's the first copy of it, if you like. And it's enough signal here to go in through the mixer tube and mix with any signals that happen to be 455 away from it. And of course, when I use my signal generator, I place the signal 455 kilohertz away from the double value of the proper local oscillator, and it got responses in the radio. Now, I may have set this up very unrealistically in the sense that the signal strengths are unrealistic. I can't remember how high I had my signal generator running to make this happen. So this is kind of an interesting deal. Except you can't use the radio itself to go looking for these things, because as soon as you tune the radio, you move the local oscillator around. You chase it forever higher. You can't really get there and tune it in. You need to do something like what I'm doing here. Feed in alternate signals or something like that. Now, what would happen if I'm trying to tune 3 megahertz? Goodness knows why I would do that, but let's say I'm trying to tune 3 megahertz, and there happens to be a powerful station sitting at 6.460. What would happen? Well, some of this might get converted to 455 and end up coming out of the speaker. And while I'm down here doing this, what I don't realize is I'm really doing this. In fact, I'm doing this, and doing this, doing this, and doing this. Now, there is a response curve in the radio that's going to suppress this stuff. And suppress even this one. Oh, my timer's going off telling me I have to go do something for a minute. Okay, hopefully I won't lose where I am in this. Okay, just a thought before I get back to this. I sat down in front of the TV. I've got YouTube on and just looking at the different videos on there, and some of these videos are so stupid it's unbelievable how stupid they are. And there they are, 500,000 views. And I get about 500 of you like to watch my videos. I'm a 500 guy, I'm not a 30 million guy. If I wanted to be a 30 million view guy, I would change my channel to something like, I could call it I Smash Old Radios. And then every video would be a 2 or 3 minute video of me hammering the daylights out of some old radio until it's a pile of mush on my bench here. And I would get rich on YouTube doing that. Yeah, think about that for a minute. Bad behavior. Pays off big time. Another thing I would do is I would put crazy thumbnails on my videos in which I would show weird emotional expressions on my face and some radio with smoke coming out of it and make some wild claim in the video title. Then I'd have thousands and thousands of viewers. Yeah, wouldn't that be a disaster? You know what? That would be a disaster in my life. 500 viewers? Hey, that's great. 10,000 viewers would be a disaster in my life, because you know what would happen? I would start bowing down to the YouTube gods and start doing stuff like you see so many other video makers doing, just to get views and get the 20 cents. Okay, now back to work. Okay, got that off my chest. So I can explain most of the stuff on this diagram. A couple things I cannot explain is, what is this doing out here? What is going on here? This is the one I want to explore a little bit today. I think everything else I came across I can explain. What is going on here? So with the radio tuned to 8 megahertz, as my signal generator passed these frequencies, 8.2, 8.6, 8.89, I got a response. Now the 8.89 is the image it's the sensitive spot in the radio for an image to make it into the IF. It's exactly 455 away from here. It's here, 455. What are these? Now, you know, you could drive an input into a radio like this, like on the antenna, so high that the radio is going to do stuff that no one would ever ever imagine or ever be interested in. What? Uh-oh. So perhaps I was doing that to some degree. Perhaps that's what I was up to. Yeah, you want to go out? You're stuck in the house? That's out, is it? That's cat language. Definitely cat language. I have to stop again. Go let her out. That's what I'm going to do. Okay. Come on, Shadow. Let's go. Let's go out. Okay. First thing I want to do is repeat this and see if this really does show up again. So I have the radio tuned to 8 megahertz. Okay, 8 megahertz. And we will verify that. Sounds like a fair bit of volume here. 8 megahertz. Okay, so we've set this rate to 8. And we'll find it on the radio. Okay, radio's tuned to 8. So now we know radio's tuned to 8. The local oscillator's at 8.45. I'm going to tune up from here and see 8.2, 8.6, what happens. This is the signal, it would be a good signal from an antenna, but not super strong. Okay, here we go. Didn't hear a thing. 8.6 would be the next one. Didn't hear a thing. 8.9 is the image. There it is. So what are these other two signals, 8.2 and 8.6? So let's see if this is a phenomenon of really overloading the front end of the radio. I'll go up. That's now a 10 times stronger signal being fed in the radio. We'll just go back down, 8.6 and 8.2. 8.21 is showing up. You notice I tried to record the relative strength. You can see I got 8.2 showing as being stronger than the 8.6. Well, here it is, 8.2. How do you get that? The signal is not overwhelming coming from the signal generator. This would be a strong antenna signal. Radio stations could do this on an antenna. If we go back to this 8.6, it's 8.2, let me write down the number. 8.224. Okay. Back up. 8.6. Something there. 8.675. Just writing it down here. 0.675. Those are a little more accurate numbers. Now, is there some wild chance that the difference between these two numbers, 8.224 and 8.675, happens to be 455? It pretty much is. 455. Wow. How's that work? 455. Just by my head calculation, which could be wrong. One signal is acting as the local oscillator for the other. Does that even make sense what I just said? I gotta stop and think about this a little bit before I can figure out the next investigative step here. Okay, well, I still haven't quite got a grip on what's going on here, but I figured out this one here, and its brother, this one. So with the radio tuned to 3 megahertz, when my signal generator is dialed down to 1956, I can hear it coming out of the radio. You notice down here, if I go lower, if I go all the way down to 1500, I can hear it. Now the reason I crossed it out is because it's obvious what that is. At 1500, there's a harmonic coming out of my signal generator at 3. Right? 3 is double. So 3 is where the radio is tuned. So for sure I'm going to hear a 3 come out of this radio. Why that? Same thing's happening down here. If I get down to 4, 4 is half of 8. Or in other words, if you double 4, there's a harmonic of 4. It'll be at 8 and you'll hear it. What's this? Well, it turns out this is just about 2, right? Just under 2. And this is just under 4. Hey, that's suspicious. If you double this, you get the image frequency. And you can hear this image frequency on this band because of the image sensitivity of this radio. So that's what that is. And the same thing works here. You take 450, 4.5, and double it. You get 9. You get what? Wait a minute. Whoa. You get 9. Why did I write 989? That's probably supposed to be 889. That is 889. I just wrote a lousy 8. It's a poor 8. 889, which is 9. So you double this, you get this, and this again is where the radio is sensitive to any frequency that's 455 away from the local oscillator frequency. 455. Right. So that's what's going on here. So this is like an image of the image. It's an image. It's coming through the image door, but it's a harmonic of my signal generator. Oh my gosh. Okay, that all makes sense. It's all quite visible. I mean, what this is opening my eyes to is that while I think I'm dialing up one frequency on my signal generator, I'm really dialing up a frequency and all of its harmonics is really what's going on. But what about these? So I've done the arithmetic up here, and it does turn out that there's exactly 455 kilohertz between the two mystery signals, which are hard to spot here, 8.2 something and 8.6 something, which are exactly 230, not exactly, but 230 on either side of where the local oscillator is sitting when the radio is tuned to 8. Tune it to 8, local oscillator at 8.455. These signals are exactly equidistant from here, 230, which is 455 all the way across. So I still haven't figured out why they're there though, and why one is stronger than the other. The stronger than the other thing could be simply because there's a response curve in this radio, and I don't know what it is, but it would look something like this when the radio is tuned to 8. There's a front end response curve, and it's also the IF I'm ignoring right now, but it's the job of the front end to get this stuff weakened out here. I mean, this is so weak. I can still hear it. This tells me a lot of things about how important this front end piece is. And that if something is causing this front end to not be that, but instead to be this, when you really want it to be this, I guess you could argue if you check a radio's image rejection and you find it to be out of the norm, poorer than expected, then you might think, well, the front end is not tuning sharp enough. And you know, when it's not sharp enough, see how low this line is? And how high it is up here, how high this curve is? So you know what you do? You turn the volume up to get this up here because you want to hear whatever's there. And by turning up the volume, you're raising the whole thing up And these guys are poking their heads out of the sand. You can hear them. Or this guy. All because the front end resonance isn't sufficient. You're not getting out of the radio what you can get out of it. Whereas this radio has a lousy front end. That's one of the reasons I'm doing this with it. But how do I know for sure that the front end response curve is anything like it should be? How would I know that? And the big military radios, they provide all this information in the manual, or much of it anyway. But not for this guy. How would you know there's a problem? And what could the problem be with the front end? The front end is basically a coil or two and a capacitor or two. So you have your, maybe it's an AM radio with an antenna coil, and then you've got the capacitor across it, the tuning capacitor, very simply. Okay, and that ends up with a certain kind of Q. Q is the shape of this curve. You can think of it as the shape of this curve. You want a higher Q, like maybe 70, 80, 100, 200, whatever it might be, to get a sharper and sharper peak here. What would drag this down? What would reduce the Q? Well, if you stuck a resistor in here, that would ruin it. Depending on the value of the resistor, you'd get less and less peak. Well, what if that resistor is incorporated in this capacitor? Just thinking this through. Suppose this capacitor is a little bit leaky. How much of a leak would you need? How big a resistor here, or how small a resistance would you need in this capacitor to start knocking this down? Now, these capacitors are usually the highly reliable mica ones and stuff like that. I tend to just leave them alone. But now I would wonder if this kind of analysis, after doing it, is pointing to a weakness of this sort. Something of this sort is going on in the front end of the radio. Then how would you even know? You'd have to replace the capacitor and see if things improve. That would be one way, but that, you've done the work. At that point, who needs to analyze anything? Just change the capacitors. And I have a principle that I follow, and that is don't do things unless there's an indication they need to be done. So I tend to leave a lot of capacitors behind because there's no indication that they need to be changed. But maybe the indications is subtle things like this. And let's remember, all this is really doing is making the radio pick up more and more stuff. Seems like a better and better radio. Picks up everything. Picks up everything everywhere. Fantastic radio. Well, it hasn't come through yet. What's going on here? And I haven't even got another notion of how to explore it further. Coffee time. Yes, it's coffee time. Coffee, fantastic. 2 sips and I got the answer. When my signal generator is tuned to 8.224, we hear it coming out of the radio, even though the radio is tuned to 8. If you double 8.224, guess what you get? You get 16.43, roughly. And if you double the other one, 8.6, 8.675, you get 17.3, roughly. So what's happening is this effect is being activated by my signal generator when I tune it to 8.2, tune the signal generator to 8.2, set the signal generator at 8.224, because there's another signal coming out of it. Just what I said before, I have to realize that my signal generator is producing a set of frequencies, not the primary one. Yeah, the primary frequency is way stronger, but all the rest are there. And so even though I have the signal generator tuned here, double this frequency is finding its way into the IF because it's being converted by double the IF. This also says if you're using a really lousy signal generator, these other signals could be really just as strong, Huh. Well, that explains them all. Every signal on here has been explained. And this also fits with what I've heard so many times and read so many times in books, that the super heterodyne receiver has a lot of problems. These are them. These are them. So if there was no harmonic in the local oscillator in this radio, if it was just one pure frequency, then we wouldn't have these other effects, even though it's harmonics from here. The only reason the harmonics from this guy are getting in the radio is because of the harmonics in the local oscillator. Let's take a look at that again. I'm going to get my SDR going, and we're just going to take a look at the relative signal strength of the local oscillator harmonics, and ponder about that. Do they not have a way of quelling them? Well, let me get this set up. Okay, let's start here. Now, radio is tuned to 8 megahertz still. I haven't touched it. The signal we're feeding in is 8.672. Not anything I really planned on. And I just set up the SDR and thought, well, harmonics go up, but why don't we just go down and see what happens? So with the signal generator set to 8.6, what do I get? Get a peak here. This is roughly exactly 4,143. Now, if you 4,100 to double that, you get 828. 828. Oh, that's right. This is the local oscillator. Or is it? Is this a local oscillator, or is this my signal generator? Good question. I think it's a local oscillator. So I'm going to adjust that with the tuning knob, Jim. Well, sure enough, there it is. Wait a minute. There's something weird going on here. This is definitely weird. So radio's tuned to 8, roughly. Local oscillator should be 8.45, roughly. Half of 8.45 is roughly 4.2 something, and I'm seeing the signal at 4.143. I think it's exactly half. It's just my numbers are a little off. Lots of plus and minus going on in here. Here's the weird thing. I'm going to move the local oscillator up frequency by tuning the radio upwards. And what does this thing do that we're looking at? Son of a gun if it doesn't go down. Yes, son of a gun. Whoa, how can that be? Okay, I'm tuning downwards. Wow, that's another mystery. Could be something weird about the SDR. I don't think so. Let me get this signal right out of here. Okay, so the output of the signal generator is not a factor now in any way. Just be sure. Just tune it, just to be sure. Because surprising things only happen if you look in places where you don't expect something. So let's go up from here. We'll go up a megahertz at a time, see if there's another a local oscillator signal. What? Okay. Wow. Okay, so 2 big signals on there. Okay, changing the radio frequency. One's moving, the other one's just sitting there. 4,800, rock solid. That's a big signal. Wonder what that is. Okay, once again, which direction is that going in? So if I tune up, it goes down. Is that the same one we're looking at? Let's go. Does this make any sense at all? Wait a minute, let me go down again. Yeah, so again, just to be sure, because lots of stuff jumps around. That's around 4 megahertz. Go up to 5. Yeah, that's the same one. Something at 48 it doesn't move. 6. Oh, okay. So sometimes the way this software operates can be confusing. And it was. Let's go back up. So there's the real local oscillator blasting away there. And for sure, when I tune the radio up, it goes up. Look at all that other stuff moving around. Is now the time to try to sort all this out? So we could argue all those moving signals are coming out of the radio in some way, shape, or form as I've been exploring. So when I look at it at the SDR screen, I can see things that are moving. I guess the best way is to do this. I can see things. This is the real local oscillator doing this. They're right in track. They're just tracking right along. So I'm going to move the local oscillator. You watch for that one thing that's tracking right along. You know what? It is not tracking right along. Okay, so I'm going to point to it, what I'm watching. I'm looking at this guy right here. Watch that guy. As I bring down the local oscillator, you know what? Darn it all. You know, because the SDR can't process changing frequencies very well. I'm going to do this very slowly. You know, I'm not going to do this. It's just too much on there to try to sort out. But the interesting question is, why as I tune up the local oscillator are there things going down? It must be... I don't know. I don't want to think about it right now because I think there's a lot of thought to get all this under. Maybe I got enough stuff. I figured out enough stuff here. Enough stuff. So we were going to look at the local oscillator and how far up in frequency and how suppressed are the harmonics in it. So that's just happening a little bit north of here, isn't it? We're right around 8. I can just tune this down, bring it in, find it, bring it in. There it is. Okay, so local oscillator is running. Let's make a nice even number here. 8. Put it at 8. So we should look really the next signal of this next harmonic of this should be at 16 megahertz. That's way up there. Let's go up one notch. We're looking for tall stuff. Okay, so this is the same one. It's just moved on the screen. Tall stuff. Tall, big stuff. What about that thing in the short wave band? No, nothing moving. Nothing moving. That's not moving. I shouldn't say nothing. Well, there's one now. 11 up and around. That one moves. That one moves really fast. See, this is another thing that I've noticed is as I move the local oscillator, let's say 10 kilohertz, some of these other signals are going to move 20 kilohertz or more. I don't really know. I'd have to do a little study on it to figure it out. But there you are. There's an oscillator. Where's my book? I'll write some of these things down. See if I can figure out a pattern. Human beings, we love patterns. We love patterns too much. We want to see patterns everywhere. Why? Because recognizing a pattern simplifies things for us. And the simplified model we get out of recognizing patterns is easier to juggle in our heads. That's why we're trying to our brain is trying to simplify everything so we can decide a couple things. 1, should we run from it? 2, should we just stay put? Everything's okay. 3, should we eat it? These are the 3 big decisions we're trying to make all the time inside ourselves. And I should run from this. Okay. Nothing like a little bit of philosophy in the morning. So we're still right close to 8, so I'm gonna call it 8. Actually, we'll put this up here like this. And then we'll go up another megahertz here. And Find that thing. Now, is that the thing? That the thing right there? That's the thing. What happened to the one on the left? Wait a minute. Did something funny happen here? Okay, so we're dialed in at 8. Let me go down again. Right, so the screen didn't change. Instead, this pointer jumped to megahertz. That's the confusing part about doing this. And total silence. There it is. So if I tune up, it goes down. $12,145 going down. Okay, let's go up another megahertz and we'll see what we get here. Okay, so this is a new one here. It's stronger. See the color here, yellow? That one's at 12,980. Which way does it go? I tune up, it goes up. Okay, let's go up and see if we can find another one. Now this is the same one here. Oh, no it's not. What happened there? I just wrote down 12,980. And this isn't 12,980. Let's go back. What happened to 12,980? Oh, I've confused myself here. So this must be the 12,980. I must have done something without thinking. That happens. 13. It's right around the same number. Right around 13. Okay, that's probably what that is. Maybe did I tune the radio? Maybe I did. I don't know. Let's keep going. So now we're up around here. Now is that one? I'll tune up. It's not moving, so that's not one of them. That's probably what I did right here. I probably did this little tuning thing and threw everything off. That's not part of the picture. 15. Okay, anybody there? Whoa, just way off on the right, just out of the range of it. So that's at 15,500 going down, going the wrong way. 15,500. Well, these numbers don't seem to have any pattern to them at all. 15,500 is it? Now let's just go up. Okay, so that'll put the 15 right here. I don't see another one. Let's go up. Here's another one, 16. So is this one here? 16,835. Are you one of them? Yes, it is. This one goes in the same direction. I figure if I gather enough information, make enough observations, it'll suddenly become apparent to me what's going on. 16,835. I'm going to crack a big nut here. 16,835. And this going up. Pretty sure if I can't do it. I was going to say, never mind. I'm going to say something stupid. I don't need to say it. I say enough stupid things. I don't need to add to it. There we go. What's moving? Okay, so the next one up is way up around 18 here. It's getting weaker all the time too. 18,035. And which way is it going? Okay, I tune up. It goes up. And I ruined the pattern I was seeing on my paper here. Up and down pattern. Okay, so I've gathered a few numbers, enough that I can look at these numbers while drinking more coffee, and maybe the answer will pop out at me as to what's going on exactly. Maybe this technique is not going to work out all that well. So I've studied these numbers. I've simply, subtracted them from each other and got these numbers. They're all pretty rough. I fiddled with the frequency setting quite a bit. So these numbers, they don't speak to me very clearly of anything other than, 13, and 26. It's kind of interesting, but I don't know if that's accurate. So I started doing the whole thing again, this time being more accurate. And there's just so much stuff going on that I've stopped. Just going to show you what's on the screen here. You would expect the harmonic, double the local oscillator frequency, then triple, quadruple, and so on. So the local oscillator is running right at 10 megahertz. I set it that way on purpose to make this easy. It didn't work. So here we are looking at the SDR now up around 14 megahertz. And you can see a number of peaks across the display. If I just, which ones are coming from the local oscillator effect in this radio. So if I tune the radio just a little bit, watch which one moves. Oh, they're all moving. They're all moving around, doing really weird things. Like, for instance, if you look, maybe this is a hint. Look right here, right where my pointer is pointing. There's a signal right there. Watch that signal and the other two around it. They come right on. They match up. You can see in the waterfall display how exact this is. I mean, this is mathematical, right? This isn't by luck. Look at all these things. Look at all these things. But there's a couple not moving. I'm curious about what those are, but they're not from the radio, I don't think, anyway. Everything that's moving is related to the local oscillator. Now, how am I picking this up? I'm picking this up in a kind of a crazy way. I've got this is the SDR antenna here. It's just going to a clip lead fashioned in a lousy coil, just throwing around the this is the IF tube, in fact. Now, this is a shielded tube, so, the fact that I've got a thing wrapped around it, that's actually not the tube I should have it around. I should have it around this tube here. What if I move it? Ow, that's hot. Don't touch that, man, it's hot. What happened? Nothing much. We get the same thing. Sometimes I like to put it kind of just in between stuff. I'm just gonna, just gonna lay it out here. Well, that's a little bit of a variation. I think what's happening is just if you get enough strength of pickup, if I can pick up enough, I see more and more signals that are in the noise otherwise. Well, that's great. There's even more signals in the noise down there to be pondered about. But right up by the capacitor is often a good spot to pick stuff up. It's all kind of the same here. There's no real dramatic difference where I put this coil. I'll put it back where it was. Okay, hey, lots of questions here I don't have answers for. These are kind of observations I've been making for years while I've been using the SDR radio, revealing this stuff. And I kind of, at first, I put it off to the SDR radio itself, being overdriven by too strong a signal. Like even now, the local oscillator is really screaming out of this radio from the SDR's point of view. If you overload the SDR, I understand these things are really sensitive to being overloaded. So a lot of the products we're seeing on the screen could just be SDR stuff. I'm using a relatively inexpensive SDR over here, one of the early RTL SDRs. And So I don't want to chase this too much because I could just be chasing SDR nonsense. Especially if they're not adding up at all. Yeah, it's too much stuff. Too much stuff here. So I think I'm going to leave it at this. Perhaps you know exactly what all these things are. Throw comments under the video by all means. Take a shot at it. But for sure, I have to put this radio away at this point and get on to another radio. Today's the last day of playing around. Lots of radios like this one. Very simple front ends. No RF tube at the front end. And they're open to all this kind of nonsense. It'd be interesting to bring in a very similar radio that does have the RF tube in the front end and see what happens. Now I have had another Hallicrafters in here. It's like a version of this radio, but a simpler version, and it was full of crap, full of stuff going on, and I didn't pursue it like I've done with this one. But I think I'm going to do this from now on. I'm going to do a little poking around with each of these simpler radios that come in, and just check for harmonics of the local oscillator. Are they there? And if they are, then there's effects from that. And what about the image and the image suppression? Something I could think about with this radio, in fact, too. That maybe is there something amiss with that? Very hard to tell. Very hard to make the measurements to get a really objective view of these things. Almost comes down to what I avoid like the plague, which is just change all the capacitors, change all the parts, change them all. Yeah, I don't think that's exactly the right solution. Well, it might be a solution. It might be a solution to a problem. This problem does not manifest itself. None of the stuff we've been looking at, as far as I understand it, I will take that back. Of course they manifest themselves. Picking up stations where they aren't. Okay, enough talk. Enough done. I'm done. Done for today. Another sunny day here. We've had like 7 sunny days in a row. The whole world has exploded into greenness out there, so that's where I'm going next. So thanks a lot for watching. Lots of stuff here to ponder and think about. But I'm going to move on to a restoration project from here. And maybe we'll drag this radio again shortly after that. Maybe. I don't know. And get some new ideas. See ya.